My name is Madan, and I'm having overall experience of 20 plus years in IT industry, out of which 8 years is on cloud platforms with DevOps tools. So I'm expertised in the field of cloud administration with the DevOps in application configurations, code compilation, building, packaging, automating, deploying, managing, and releasing code for different environments. Have delivered AWS and DevOps training for more than 45 batches successfully till date. Having online training experience for more than 6 years on various cloud administration and DevOps tools. I'm also certified solution architect associate and a certified Kubernetes application developer. Introduction about myself. So we will be going to understand the course details related to the certified solution architect associate for AWS. The course content anyway, I will be explaining you in few minutes after completing the requirement of why to learn this cloud and other things. And then after that, I will be explaining the course content. So cloud computing. So before the cloud, normally 20-25 years back, no, normally every company used to purchase physical servers. They used to purchase physical servers. They have to procure whenever they get a new project. The basing on the project, they have to procure the new server machines, servers, and for servers to maintain that administrators are required, and these servers normally kept inside a data center. Every company used to have their own data center. The data center is nothing but a building in that they will keep all these servers. So these servers are again interconnected with various LAN network, and basing on the requirement of the development team, the administrator has to deploy the software into those servers. So once the project is completed after 1 year or 2 years, then once it is delivered to the client, then the servers may be reused, which they purchased already, or they may not reuse, because after 2 years, maybe at the time the latest softwares whatever coming into the market, those softwares may not support the existing servers. Sometimes some support, some may not support. In that case, the company has to again they have to purchase for the new project after 2 years or 3 years, like that. So that means companies have to regularly invest money on the purchasing these servers. So this way, a lot of hardware. If you see large companies like big companies like Infosys or any company, Wipro, if you take example, you will find a big, huge room with all these unused CPUs, all these computers, etc. They used to keep in in the storage room, which are unused. That means they actually that is also not good for the environment. So that is the reason. Slowly, what happened is these cloud providers came into picture. Cloud providers, what they do is cloud providers in the sense we have AWS, Amazon Web Services, we have Azure and from Microsoft, we have Google Cloud Provider from Google. So and Alibaba, many are there. Out of these, the famous are AWS, Azure, and GCP, as you know. So these providers, what they said is that as of now, lot of startup companies are coming. Lot of startup companies are coming. Every startup company, they are not interested to have their own data center, so separate building and procuring the servers in the data center, it's actually a huge investment. Huge investment. So that is the reason these data centers they are preferring mostly the cloud providers. Why? Why? Because these cloud providers, what they do is they will have very modern infrastructure. They will have very modern infrastructure. These cloud providers also maintain separate data centers at various locations. For example, they may maintain servers in Mumbai, in Hyderabad, in Chennai, like that. They have their own buildings. Every cloud provider have their own buildings, data centers. So in these data centers, they have latest modern physical servers. Now, whenever anybody want, for example, the startup companies, if they want some 10 machines or 20 machines, for example, even one machine also, if you require, you can rent it out. You can rent it out from these cloud providers. You can pay some X amount. So they charge you per second, actually. They charge you per second. So that is cheaper, actually. That is cheaper. For example, if the company want to use the servers for 1 month or 6 months, for example, after 6 months, they can use the servers by these providers by renting it out. After 6 months, once the project is completed, they can pay for the 6 months period, and the servers can be taken back by the cloud providers. That means there will be remote activity, remote access only. They cannot access them physically, of course. They can connect remotely from their workstations. Every startup company from their workstations, they can connect remotely to this cloud provider provided physical infrastructure. So they can remotely access them and they can pay it. Every month the billing will be generated. Every month they have to pay. Very simple. So no need to buy any physical machine by the emerging companies or the companies which are coming recently now. So they don't need to involve into preparing any data centers. Not require any data centers. They can purchase and they start working. So this way, the startup companies, once they do, if they do the POC, for example, initially they will do the proof of concept. They will develop the proof of concept for the client, and if the client is happy with that proof of concept, then the project, then they will get a project. Once the project they get, they can deliver it, and that's all. So that's all. They have to pay the rent for it. That's it. Simple. So this way, no need to purchase any hardware. That's in a simple idea and overview I'm giving you. So if you needed a server, you had to buy it, install it, maintain it, replace it, have an IT team to maintain these servers. And also the IT team also need to, the administrators need to do networking, that is LAN networking. They need to install database softwares. They need to add users so that they can connect to these newly physical machines by using user management tools, and many more you have to do before the cloud came into picture. Now, cloud computing is a computing paradigm shift where computing is moved away from the personal computers or an individual application server to a cloud of computers. So, cloud of computers. So, cloud computing in the sense, under the sky, wherever you are, you can avail the infrastructure on rent by providing by any cloud provider. Wherever you are, you can access it. Okay, so wherever you are, you can access it, and users of the cloud only need to be concerned with the computing service being asked for, as the underlying details of how it is achieved are hidden. So they will provide you a GUI as you purchase products from the e-commerce websites like Amazon. How you purchase the things, same way they are also having their own website. From there you will not purchase, but you will rent out. You will rent out their infrastructure. Whatever you want, you can rent it out. Even you rent it out for 1 minute also, 1 hour also, one month, 1 year. You can rent it out for as much time you want. This method of distributed computing is done through pooling all computer resources together and being managed by software rather than a human. That means there will be no human intervention. So everything will be same like how you buy a product. There will be no human intervention, right? So you will select, you add them to the cart and you pay it. That's it. It will be delivered to you. The same way it will here also. So you can no human intervention will be there. You can choose whatever you want and you can get access to those infrastructure remotely. Possibilities. So it is possible to consolidate all the needs of an organization in a systematic and accountable fashion. It is possible to procure computing related resources similar to how you rent a place for a living. For example, you can rent storage on demand from AWS Cloud in a service it offers called the simple storage service. They are having many services. They named it, every service they named different way. Every cloud provider they named them in different way. So first of all, I also need to explain you physical machine. What is physical machine? What, of course you know what is physical machine. What is virtual machine? We need to understand. So on the cloud, you can rent out a physical machine also. You can rent out a virtual machine also. The difference I will later tell you. But for now, if you want a storage, you can rent it out. They named as S3 in this cloud. You can rent computation service from AWS Cloud and in its Elastic Cloud Computing service EC2. So Elastic Cloud Computing is a name given by AWS Cloud provider. It's nothing but a virtual machine. It's nothing but a virtual machine. Virtual machine is nothing but a logical partition. It's a logical partition on a physical machine. On a physical machine, using some tools like hypervisor, we can create multiple partitions on a physical machine. And each logical partition, in that each logical partition, you can deploy a operating system. On top of it, you can deploy your applications as you do on a physical machine. The same thing you can do in that logical partition. So that such logical partition is called as virtual machine. So that means if in a single physical machine, you can have multiple logical partitions depending on that physical machine's capacity. So basing on that, you can suppose you have assume you have 10 logical partitions on the physical machine. That means you can treat them as 10 different machines. 10 different machines. And the end user, they feel that as if they are using a physical machine actually, whenever they connect remotely, but actually they are using a virtual machine or a logical partition. So the people who are working from work from home, whatever they're doing, actually they are connecting to a virtual machine and they are doing their regular jobs actually. Right. So those also you can rent it out. So AWS cloud provider, they call this as EC2. And if you go to Azure, for example, they call it as virtual machines. So like that, cloud to cloud, they give the different names. That means if you know AWS, then you can easily understand the other clouds as well. One cloud is, if you understand, the remaining you can easily learn. Why cloud computing? Pay per use. So you pay per use. Instant scalability. Suppose today the product is going on. Suppose in suddenly you want 10 machines or 20 machines. Suppose then you can easily get it. You can get it. But if you go back 20 years, 25 years back, in those days when you want 10 machines extra, then you have to put a order to the vendor. So the vendors will take some time, 1 week time. After 1 week time, they used to provide the machines what you want with your configuration. But here it is not like that. Instantly you can get whatever machine, how many machines you want with what configuration. You can choose the configuration also. For example, I want 16 GB RAM, 32 GB RAM, or even 128 GB RAM. Any size you ask, they have it on the cloud. You can choose them and you can use them. And then security. So previously, when you are managing your own physical machines, you have to take care of installing the antivirus, etc. But now the cloud provider itself, they take care of it. And moreover, you don't need to worry also. Suppose you are using a virtual machine, in that you chosen to have Windows operating system. You can choose Windows, you can choose Red Hat or any Linux flavor you can choose. So whatever you choose, suppose if you choose on Windows, then for Windows, using Windows you require licenses. So the licenses also we no need to worry, because they already have the licenses, and they pay for that, and we have to pay the bill whatever is generated. The license is also part of that bill actually. So that is also very minor bill actually. So that we have to pay. So everything they will take care under the security and reliability. So as you know, for example, if you are accessing Amazon e-commerce website, so whenever you access it, whenever you browse it, you will automatically you will get access to the website. But you never saw something like 404 404 error, never, right? So whenever you open that URL, you always able to access it, and you able to add the product, buy the products online. So it was never said there that the site is down. They never said. That is called the reliability, right? So the application, wherever they deploy, normally applications developed, right, and after that they deploy in a server. So the server should be running 24/7. If the server is not running 24/7, if the server stopped for some reason, then no, you whenever you accessing your application, the application running in that server is already stopped, you cannot access it. But in real time, you will not deploying your application in one single server, right? You will be deploying your application in hundreds of servers, depending on the how many people are connecting every day. Basing on that, they will deploy the application in multiple servers, thousands of servers they deploy. If every day 50,000, 60,000 people are accessing your application, for example, then you require easily 1,000 or 2,000 servers to be there. So if one server is down, no problem, you will be automatically reconnected to the another server. But even you reconnected to other server also, if you are not able to access your server, means the server is down. That means your clients feel bad about it, right? They will move to another e-commerce site, because if it happened multiple times, for example, then they will definitely go to the another site which is running regularly 24/7, for example. In that case, they will move to that other site. So that is the reason, for a business, the application should be running 24/7, 365 days regularly. So that is the reason they said in the reliability, they saying reliability. Reliability means if you deploy your application on the cloud, they're saying that your application will be always available, always available. So you don't need to worry whether the server is down or not. You don't need to worry. We will be taking care about it. So that's the reason most of the people, most of the companies are moving to cloud. And APS in short, it is a application programming interfaces actually. So that means that there will be developers who will need to connect to the cloud using their programs. So they will write programs such a way that they want to communicate with the resources running on the cloud. In that case, they need some APIs, some interfaces between their application and the cloud. So every cloud provider having their own APIs. So using that APIs, that a Java developer, a .NET developer, or any developer, they can use those APIs and they can able to connect to the cloud, and they can connect to the resources whatever they're on the cloud, and they can do their activities. So essential characteristics of a cloud: on demand self service. So no human interaction is needed for resource provisioning. Resources can be provisioned with a click of a button. So that means you same like no, when you buy any products on the e-commerce website, you add them to the cart and you pay them. That's it. With all the happens with a button click. That's it. The same thing here. This provisioning is available 24/7. So whenever you want, you can create your resources on the cloud. So you require network for this. Broad network access is required. Resources can be accessed from anywhere using the network. Need high broadband to access the resources. No physical access is required at any time. So physically you cannot access, but remotely you can access their resources. And as resource pooling, physical resources are shared between customers. Physical resources are shared between the resources means every physical resource will have multiple virtual machines. So that means every physical resource can have 10 virtual machines, and these 10 virtual machines can be shared between 2 or 3 customers, like that. So the cloud's control center, or the cloud's data center, decides which physical resource to be allocated for a customer's virtual services. Suppose you remotely you demanded for I want 2 machines. 2 machines means 2 virtual machines. Then those 2 virtual machines, again you have to select where you want, because they're having data centers everywhere, everywhere. So they call them as regions. They call them as regions. So for example, if you want a machine, for example, here if you see here, so for example, I want to launch an instance, for example. This is an instance, it's a virtual machine, you see, it's a virtual machine. So where you want to create this virtual machine, you have to select it. Here is a various regions. So worldwide, we have various regions. So United States, we have these regions. Asia Pacific, we have these many regions. Canada, Europe, like that, we have various regions actually. So you can choose where you want to create your server. If you want to choose in Mumbai, you can select Mumbai and then you can create the resource over there. So this way, you can select the region and when you said I want a virtual machine and how many virtual machines you said, that again depends. So what you typed here, number of instances, how many you want? I want one or two. You can mention over here. You can mention over here, and what OS you want in that virtual machine. What OS you want? Amazon, Mac OS, Ubuntu, what you want. You can select the operating system in that virtual machine. You can select them and what type of hardware you want. For example, if you take T2 Micro, it contains one CPU core and 1 GB RAM. But if you want some more better one, so you can go for T2 Medium. It having two CPU core and 4 GB RAM. If it is not enough, then there are many options are there. There are many options are there. You can choose them. You can choose them 4 core CPU and 16 GB RAM. So like that, you have many types. So here you have the instance types we have here. If you open it, you will find various types of resources here. Different types have different names actually. So number of CPUs. So even you can get 48 core CPU also, which is not available in the market. You can have even 192 GB RAM also if you want. So like that, you can choose whatever you want. And once you choose on them, and once you submit, then now the cloud provider will randomly select one of the physical machine. In one of the physical machine, they will choose one of the virtual machine and that will be given access to you and you can access it and you can do your regular activities what you do with the physical machine. You can deploy your software, you can do whatever you want in that virtual machine. Some advanced cloud services allow for dedicated physical resources which are expensive. If you don't want a virtual machine, you want a complete dedicated physical machine, you can have it, but it is expensive. It is expensive. So rapid elasticity, the resources can be scaled up and down as needed automatically. So normally in olden days, 20 years back, no, if there is a demand for their application, for example, suppose assume, of course, in those days, no, 20 years back, we do not have e-commerce websites at all. From past 15 years, we're having actually, but 20 years back, we have very less websites, no, very less websites. We do not have any e-commerce websites in those days anyway. But take an example. Suppose you are using physical machines and now you are not using cloud and you have already 100 machines allocated and in that you have deployed the one of the e-commerce website and like Amazon and people are connecting to that regularly. Every day people are connecting, 1,000 people are connecting to that website, for example. And this website is offer giving some offers, for example, offers are giving some discount, some 50% discount they are giving, then the traffic will be increased. Normally every day 5,000 people are coming, but before the offer period is only for example 4 days, for example. So in these 4 days, more people, there is a good chance of more people logging into your application to purchase your products, which are available on cheap. So 1,000 people instead of 1,000 people, they may be 400 people, maybe more. 1,400 people are coming now. So these 100 servers are not sufficient. So what you will do normally, if you are not using cloud, you will be buying 20 more machines or 30 more machines, physical machines, or you will be buying two or three machines and you will be deploying more applications in the virtual machines, for example. End of the day, you are going to buy some physical machines to add more virtual machines, for example. So if you are using the same cloud, for example, in that case, in the cloud, we have a service called auto scaling services, auto scaling, a service called auto scaling. So using the auto scaling, what happens is that you can, it will take care. You can tell it that if there is a demand, automatically grow as per the demand, automatically grow as per the demand. So that means here on the left side, we have an option called auto scaling. So if you click on this auto scaling, so it helps maintain the availability of your applications. So auto scaling groups are collection of Amazon EC2 instances that enable automatic scaling and fleet management features. So this is a service we are going to use in this case. So what happens is that auto scaling service, what we do is we will configure it. We'll configure it that regularly I want 100 machines, but if there is a demand, suppose these 100 machines are occupied, that means the CPU utilization is more than something 70% on all those 100 machines. In that case, you create 10 more machines. Like that, we can ask like that. So up to how much you can increase, you can set the limit also. Maximum how many servers it can grow, you can limit it. So automatically your auto scaling service will grow the virtual machines. Once the offer is completed after 4 days, automatically your auto scaling service will do what? It will slowly it will remove those extra servers and it will maintain the same 100 machines. That means extra machines 20 whatever created, those will be terminated. And you manually no need to do anything. So you have to set it in the auto scaling service, rest it will take care. Such services many are there for various different purposes. So no need to purchase the resources for a one time peak scenario. So you need to purchase measured services. Payment is done only for resources you actually used, basing on the server time, how much server time you have used, how much DB storage you have used, etc. Measurements usually done in server time by second. Per second they charge you actually. No need to pay for unused resources. Unused resources means, for example, you rented out a virtual machine, for example, and for some reason you stopped it. You can stop your virtual machine also. So when you are not using, for some reason, if you want, you can stop it. So here are the some options here. You see, the grayed out because I don't have any instance now. You can stop instance, you can start instance, you can reboot, many things you can do. So when you stopped it, for example, then what happens? The CPU, the RAM is not used at that time, but your hard disk will be used, right? Because in your hard disk you having your data, so they will charge you only for your hard disk. But they will not charge you for your CPU or for your RAM. So this way they will be carefully generate the bill. So the bills will be generated. The bills will be generated monthly wise. They will generate. On the right side, you have a billing option. In there, you can see the bills generated monthly. The bill will be produced to you, and you have to pay for that. And we have three types of clouds actually: public cloud, private cloud, hybrid cloud. Public cloud is the one we are learning: AWS, Azure, Google Cloud. These are all comes under public. Private are nothing but the data centers which are used by the respective large companies like Infosys, Capgemini, whatever they are. They are using their own data centers. Those are called private clouds. And hybrid. Hybrid means it's a combination of both public and private. We'll see that in a bit better. The cloud is set up in a public network, managed by large companies, accessible through the internet, available to all clients and users. Clients have no access to underlying infrastructure. So anybody can access it. You, me, everybody, anybody can access this infrastructure, and these are maintained by large companies like Azure, AWS, and Google. And you have to pay for that as much as you have used it. But you cannot access them physically. You cannot access, but you can access remotely. And comes the private cloud, a cloud set up in an organization's premises, managed by organization's IT team, accessible only in the organization's network. Only the employees can access these servers of that company. Available to users in the organization, uses private cloud infrastructure. So that is only for their company employees only. Hybrid, a cloud setup in a organization's premises and also connected to the public cloud. That means it's a combination of private and public. Workload can be separated between the clouds, two clouds. That means sensitive data in the organization's premises, like your database. Suppose every web application. I'm not sure your background. If you're not understanding, anyway, this is just a demo. So I'm not getting into depth. But assume there is a web application. Every web application involves a front end and a back end and a business layer also there. But if you take database where the front end will get fetch the data, the database you can store in a company's on-premises data center itself in the private cloud. You can keep it there only, but the front end you can deploy in the cloud virtual machines. You can use virtual machines to deploy your front end applications. Right, this way you can move your resources properly. So that means front end, if somebody hacked also, no problem. You can redeploy your front end application again. But if somebody hacks your database, that's problem, right? That is the reason. Company, but even though you can move database to the cloud also, because cloud nobody that easily they cannot hack it actually. Already many companies already doing it. So now comes to types of cloud service models. We have three types of service models. One is, so I told you, right? So here AWS is servicing, giving a service. What service it is giving? They're renting it out. They're renting it out their infrastructure, right? So that is AWS or Azure, Microsoft Azure or Google. But we have different types. So these types, whatever we're just going to learn, no, those comes under IaaS, infrastructure as a service. That means these people, AWS and Azure, Google people, they're renting out their infrastructure as a service. For this service, whatever they're providing, they're charging you actually. For that, they're charging you, right? Similarly, we have PaaS also there. It's a platform as a service. It's a different kind of service, platform as a service. And finally, we have software as a service. That means we have three different types of services. Normally, the jobs we see on the job portal mostly are related to your infrastructure as a service most of the time. Okay, the remaining two are very rare, but we'll understand those as well. So IaaS, infrastructure as a service, the cloud provides the underlying infrastructure. For example, computing services, networking services, storage services. The client, that means we handle and is responsible for all the rest. All the rest means what? You got a, see, nowadays also people they buy assembled machines, right? They buy assembled machines. So assembled machine contains what? You will configure it, right? You will ask him, you will tell him, you give him a list of requirements, how much RAM you want, CPU you want. Once you give that, he will prepare your assembled system to you. After that, you decide what OS you want to install, etc. But if you buy a laptop or anything branded, it comes with default Windows 11 or some Linux version. by default, right? So there you will not have much control. So here also, this AI is giving you a assembled system. You can choose whatever RAM you want, CPU how much you want, everything you choose. After that, you do the rest of the things. The rest of the things means you will deploy as per the development team's request. What OS they want to have in that system, you can deploy that, and what other software is required by the development team, you deploy them. And finally, the application what they written, that also you deploy. So then the application will be start running. So then they can test it. But if they can use it for development testing or SAT testing or UAT testing or production, for any purpose you can use it, right? So this is everything. You take the rest of the things actually. So most common examples are virtual machines. So in infrastructure as example, one is virtual machine. The cloud provides a host machine, networking, disks, etc. The client creates a virtual machine, installs software on it, patches it, maintains it. So it do a lot of things actually. Once, see, as you know, many things you can do as a physical machine. What you can do, everything you can do on this machine now. That means as a DevOps engineer or as a cloud administrator, you have to do everything once you got the brand new machine. Then PaaS is somewhat different. The cloud provides platform for running applications. That means they're saying that everything. That means they're giving the platform for running applications. That means you can directly run your application. That means including, not only including compute, networking, so these things we are getting in the IaaS. But if you're using PaaS, you get some extra. That is runtime environment. Runtime environment means runtime environment is a software. Is a software. It runtime environment is will be having for Java, will be having for .NET, will be having for Python, uh, for Node.js. Like that, for every software you have a runtime environment software. What is that? The runtime software is environment software is mandatory. So suppose, assume you are deploying a Java application told by the development team. So before you deploy, you must deploy Java runtime environment. You must deploy it. Why? Because without the JRE runtime environment, you cannot able to run the Java application. Java application, when you start to launch, it will not launch. It will complain saying that I could not see a runtime environment. So a runtime environment is mandatory to install, which is required actually. Whatever the developers written in the Java application, the instructions, whatever written in the Java application, need to be sent to your operating system. So your in between a software will be there like runtime environment. This runtime environment takes your instructions coming from the Java application, and it translates and gives back to the operating system underneath. And your operating system will communicate with your kernel under that physical machine, under that virtual machine. So that means it is a mediator. Runtime environment is a mediator. So previously, when you are working on IAS, so everything you have to take care. JRE also, if it's Java runtime, then you have to install Java runtime. If it's .NET, you have to install .NET runtime. So everything you have to take care. But here, when you are using PaaS, platform as a service, they have options actually. They will provide options for you. So what is the runtime you are using? I mean to say, what application you are using? Java. Then they don't know. They will provide the runtime environment automatically. Of course, they will show you. Again, in runtime also, you'll have various versions. So again, developers will tell you, see, this is our Java application, and this is a runtime environment we want to use. Runtime environment have different versions again. They will tell us, the runtime environment should be of so and so version. If you choose any other version, it will not work. There are Java application will not work. So they will tell everything what version they want. So when you are using a PaaS as a service, platform as a service, they also provide the same thing. Runtime environment, which version you want to choose. They will provide it. They ask you. When you select those versions, then they will automatically install it. That means you are not doing it manually, which were you doing previously in IAS. But here, no. You have to choose what runtime you want. And the scaling information, if there is demand, how many servers to be increased, security updates, patching, everything they will take care. Everything they will take care. Before it was we have to take care. Now in the past, they will take care everything. Then what we do then, the client just needs to bring the code to run. You just need to upload your code. That's it. You just need to upload your code. Wherever your code is there, you just upload it. That's it. Rest they will take care. Okay, so this one comes under PaaS. Examples are web applications. The cloud provides the runtime for running the web apps. The client uploads the code and it just runs. The client has no access to the underlying virtual machines. SaaS, software as a service. No hardware or software to manage. Service delivered through a browser. Like you see, you are using team meeting. We are using team meeting. It's a service. Team meeting is a service. We are using that, right? So it is Microsoft product. So using the team meeting, we have to pay for that. So using this service, we have to pay annually or quarterly. We have to pay for that using this software. So your team meeting is an example for SaaS. One of the example for SaaS. Like that, you have many such so applications are there. You can use from using the browser. Like for example, if you're using Salesforce, for example, Salesforce is also a comes under SaaS. They having the complete package. If you want to use their Salesforce application, you have to buy their licenses, and you can access them from the browser again. So that is a SaaS. So a software completely running in the cloud. The user does not need to install anything on premises on his or machine. The provider of the software take care of updates, patches, security, etc. Example: Salesforce, Office 365. These are all SaaS based. So example here on premises. If you take on premises, if you do not have cloud, if you are not using cloud, then everything on the on premises on the data center. On premises means the company's data center. On the company's on premises, you have to install everything, every layer you have to take care. Okay, once you get systems for physical machines, then you have to connect them using LAN, storage, everything you have to take care. But in the IAS, that is part of our course now. In this course, what we do is we will everything is available. You have to start from selecting the OS, which OS you want. That is the reason before when you are learning here we choosing what OS you want. Here we choosing what OS you want. So this here we select. Our work starts from here. So everything is ready. Everything is ready. You just select your OS. And rest ref middleware runtime data everything you have to take care. But in platform as a service you need to upload your code. Rest everything is available. OS also they decide what to have, everything. Software as a service, so software as a service nothing is there, everything application also belongs to them only, right? We have to use, if you want to use them you can use them, and you have to pay that as per their payment system. And advantages what we get here, because if you're using cloud, what advantage you get, you are not buying any physical machine, that means lower cost of ownership. Now you are not purchasing anything, right? So reduce infrastructure management responsibility, reduce infrastructure management, no management at all, right? Otherwise if you have your own data center you have to manage everything. And if you see here, if you go to the instances here, in the instances what happens is that once your project is completed of 6 months, then what you do, you simply click on terminate instance. This is the last option, you can choose terminate it, that's it. Once you terminate it, your billing stops there itself. So like that you can work on it, so no responsibility on you, right? Once you used it, you terminate them. Allow for unexpected resource loads. Whenever there is a demand, automatically your cloud will take care. Faster application rollout. So this way, your application is also deployed very fast, and you can see the results. And if any bugs, they can fix it again. They will deploy it. So everything will be faster. So multi-tenanted. As I told you, every physical machine have multiple logical partitions or virtual machines. Those can be given for on rent by your cloud provider with different people. So it's multi-tenanted. Virtualization lowers cost by increasing utilization. Because of virtualization only, this is possible, right? So without virtualization, we do not used to have virtual logical partitions, no virtual machines, right? So because of that, we are able to save a lot of money. So now let's understand the course content of this course. So here in the course, I will be introducing the cloud, which I have just explained, different segments like SaaS, PaaS, and IaaS. What are they? And the cloud deployment models and essential characteristics of cloud. Creating AWS free tier account. Once we create a free tier account, we will be understanding what are regions, availability zones. Of course, I will be also explaining about networking, what is networking, basics which are mandatory, right? For people who do not have any such background, then I will explain those as well. And then we will learning creating the various resources like EC2, deep learning about security groups, enable different ports. What are ports first of all? Why we require ports? Why we require security groups? Those things we discuss actually. And different IP addresses, why we have these many public, private, elastic are there. So why we have these many, what are the advantages we get by using them. And then Amazon machine images. Machine images are nothing but no. For example, you bought a new machine, assembled machine, then you want to install Windows, for example. What you do, you will have a pen drive. In the pen drive, you have the ISO for the Windows. You will insert that pen drive to your machine, and you will start installing it, right? So that ISO is nothing but a image. We can call it as a image. So here we have different AMIs also. We have different AMIs. So if you come here, so in these instances, when you launch an instance, when you say every here it say they're saying this as Amazon machine image. These are all images. These are all OS images. OS images. These are all images. Every image will have a unique ID actually. So what are those things we can discuss later on. But we will be discussing about default images, default AMIs. Default AMIs means these are all default AMIs. Whatever we saw is these are all default AMIs. So you can have your own AMI also. You can create your own AMI also, custom AMIs. So how to create custom AMIs and why we have to create a custom AMI, that also we will be understanding. And then creating different storage services like S3, simple storage service, Elastic Block Store. Elastic Block Store is nothing but your volume hard disk. It's a hard disk, right? So we call it as here as EBS. And then Elastic File System. It's Elastic File System is same thing, right? No, if you are working in a company, you will be sharing a folder, for example. That folder will be shared between your colleagues, which are the same LAN, which are on the same LAN. So whenever you want to share your folder, you use internally NFS, right? The same way you have EFS. So we will discussing about that later on. And IAM, identity access management. That means this is mandatory. So whenever you're working as a cloud administrator, so whenever you connect into the cloud, you will be connecting as an IAM user. You will be connecting as an IAM user. So IAM user will have a specific permissions. Suppose we are all working in a company, I will have some permissions, you will have some permissions. So each will have individual will have their own respected required permissions. That means on the cloud you cannot create whatever you want. You will be restricted with permissions. So only those resources you can create, nothing more than that. So for that, as a root user, as an administrator, we have to assign permissions to each user. So one will be administrator will log in as a root user, and he will give the permissions to the individual users. Of course, the request coming from the manager. The manager will send a list of employees, and basing on that, what requirements, what permissions they want, they will list it out, and basing on that, the administrator will provide the permissions to individual users. So those users log in as a IAM user. So the next is user group and roles. These are all used for this creating the IAM user. These are components actually. We'll learn both in depth later on. And then we will be learning a CloudWatch, introduction to CloudWatch and concepts. CloudWatch is a resource which will watch the your infrastructure activities, how the CPU performing, how the RAM performing, right? So various things. It will check the health. It will monitor actually. It will monitor. If anything goes wrong, it will inform us. It will inform us through emails. So by getting the email, then we can attend the issue and we fix the issue. Configuring the cloud trails. CloudWatch is watching the infrastructure, and CloudTrail is the one which will watch the user activities. So, for example, in a physical data center, if you accidentally switch it off the server, for example, so nobody can notice it. But in the cloud, it's not like that. If you accidentally terminated or stopped an instance, for example, accidentally, then automatically this will be tracked by your CloudTrail. CloudTrail will track who did what at what time, what activity it did. Everything will be tracked by CloudTrail. So it tracks your user activities. CloudWatch will track the infrastructure activities. And then we will be learning about the virtual private cloud. So virtual private cloud is like, no, you can think it as a mini data center. You can think as a mini data center. So what is data center? Every company will have their own data center. So in the data center only, they will have the infrastructure, and those are allowed access only to their employees, right? So same way on the cloud also, so I am having a account in the cloud, you also having an account in the cloud. For us, they will giving us our own data center. They will giving us our own data center. So as you know, whenever you say data center, you will feel like more secure. So that means you cannot access my resources, I cannot access your resources. We will have our different data centers. So your VPC can be treated as a data center on the cloud, or we can think it as a virtual data center. So, and now in the data center, what you have? In the data center, you will have your infrastructure, everything, right? The same thing you will have in the VPC. These are all the components we are going to learn under the VPC. So, like, no, you need to learn about network basics, so public IPs, private IPs. You have to learn about CIDR range, how to create a custom VPCs, custom subnets. What are subnets? All this I will explain later on if you don't know already. Even you know, I will have to repeat it anyway. CIDR range calculations. So these things are explained. So VPC and subnets, NACLs, network access control list. So route tables, internet gateway, NAT gateway. What are all these? So creating a NAT instances, configuring web applications in VPC, VPC peering. What is VPC peering? Why it is required? VPC endpoints like gateway endpoint and interface endpoints. What are the and why are they required? Right, many more are there. Okay, I listed out few, but few others also there. I have not mentioned here. Those also I will, because those are all small topics. So I just to fill this sheet I can mention here, but many other topics also there. Those will be learning. And I have not mentioned about the transit gateway also. So transit gateway is very important. Okay, transit gateway is very important. So that also we are going to learn, right? Transit gateway. So when you are using peering, so in the peering, you will see some issues when you have more number of VPCs. So then at that time, you can use transit gateway, which is very much helpful. So what is that also we will learn later on. Those also we will learn later on. And then creating auto scaling group. So I just now give an example, creating a target group. So it's a part of these are the components under the autoscaling. What a target group is. Target group, these things we'll learn slowly. Launch configurations, configuration of autoscaling policies, advantage of using autoscaling with elastic load balancer, right? And and before that, we shall also learn about load balancing. Because as I told you, right, take any e-commerce website. Those are running in thousands of servers. That application is deployed in thousands of servers. So whenever you open the URL of any Amazon site, for example, then your request will be sent to one of the request. We have assumed 1,000 servers there. Your request should go to one of the server, which is not busy. So we will decide your request to go to that particular server. Your load balancer will decide that. So why we require load balancers? Those things will decide, because load balancer is a mediator. Is a mediator. Like no, when you're accessing your load balancer, no, he can see how many servers are there, how many are busy, how many are not busy. He can watch it. And when a request is coming from you, it understands your request, and it will because he knows which server is not busy, it will send that request to that particular machine. So he's a middleman. It's a middleman. Okay, he's a middleman. So it is in that we're learning what different types we have: classic load balancer, application load balancer. We have network load balancer also there. That also we learn. Cross zone load balancer, sticky sessions, elastic load balancer, access logs. Those things we'll learn. And then we also learn about backup. How we can take backups of our applications, our resources. That also we learn backups and backup strategies. And we also learn in depth about Lambda, how to configure with AWS services using Boto 3 and Lambda layers. What are Lambda layers? Many are there. I have not mentioned here. So we'll be spending good time on Lambda. And then we have a topic called simple notification service, which is used to send notifications via SMS, via mail, or to your web application. You can choose different ways using SNS. So your CloudWatch, for example, your CloudWatch, I told you, CloudWatch will send you mails whenever your RAM is used 80%, CPU is 80%, for example. In that case, your CloudWatch want to alert you. In that case, your CloudWatch will take help of your SNS only, because SNS is a specialized service which knows how to send a mail to you or SMS to you. Those things it knows it. So that means services also interdependent on other services. So for that, suppose if your CloudWatch want to communicate with SNS, then CloudWatch require permission. So those permissions we have to give using the roles. Actually, here we have a roles concept. So roles concept are used to give permissions between the services whenever they want to communicate. Amazon simple queue service. This another topic. So when I explain deeply later on, but this is normally it's like no. If you're having multiple microservices, you are using microservices. Then, as you know, microservices we'll have assume you have 20 services, microservices, and 10 services are sending some data. Another 10 services need to consume this data. For example, in that case, the microservices will send data to your SQS, and from your SQS, the remaining 10 services may fetch it like a consumer and producer, like that concept that I will explain later on at the time. And then elastic kubernetes service. Elastic kubernetes service is normally it's about no when you have this is a different topic actually. This is for this no to use this one you should know what is Docker, and you also know what is Kubernetes. If you know them, only then you can understand what is EKS. So for that reason, I will spend some good time over there. I will be giving some examples. What is a Docker? What is a Kubernetes? Why we require Kubernetes? And we'll see some examples. And then we will use EKS. So here I will not directly tell you what is EKS, how to launch it, but I will explain you first of all Docker and Kubernetes, and then we will use the EKS. That way I'll explain there. And then we have RDS. So RDS is a relation database service. Okay, relation database service. That means RDS supports a bunch of database engines. That means it supports SQL Server, it supports your Oracle database. Many databases are there. So it's under this RDS. It's under this RDS. So if you go to RDS, for example, in this you can see multiple database engines available. So you can select whatever you want. You can use them, right? So for example, if you go here and if you click on create database, you can see here we have these are all engines. You can use MySQL, Aurora, PostgreSQL, MariaDB, IBM SQL Server, Oracle. These are the database supported. So if you choose any, you can choose any one of them. These are all comes under the RDS. So those that also will be learning at that time. And then we'll be learning about AWS CLI, command line interface. So whatever you are doing, what these are all things we did by you connecting your UI. This is your UI. So whatever you want, you select your UI. If you want to create instance, you select your UI. You click on this button, everything you do. But you can also do it using command line interface. We have APIs, we have commands. Using that commands, you can execute them on your Linux machine, and you can execute and you can do whatever you did using the GUI. The same thing can be achieved using CLI. We'll learn how to do that. And then CloudFront. So CloudFront is another topic. When your application need to be more accessible, more accessible, then you can use CloudFront. So CloudFront internally have its own servers called edges. So whenever people are accessing your application, suppose you are accessing from Mumbai, in one of the region, somebody accessing from Chennai, some region, nearby region, then now the server is deployed in, for example, in the main region, somewhere in Bangalore. When they're accessing from Mumbai or Chennai, then a copy will be stored in that Mumbai region, one copy, and one copy in the Chennai region. So next time when you request the same web page, the request will get from the edge location from that Mumbai or Chennai region. It will not go to your main server, which is in Bangalore. So this way, the latency will be very low. With the lightning speed, you can access the site web pages. So that is about CloudFront. Anyway, that we see practically, and also we see API gateway. Normally, the API, we learn this with an example API gateway, and then AWS security. We will learning security. What is security manager? What is key management service? What is certificate manager? Those things we will learn. And here I have not mentioned about Route 53. We will learning about Route 53 as well. Okay, we'll be learning about Route 53 as well. So you can purchase. We'll see. I will show you how to purchase your own domain name and how can we use Route 53 so that no you can use your domain name to. Before what we do now, when you are learning EC2, we will be deploying our application in EC2 instances, and we will be accessing those application using the public API of the EC2 instance. But later on, when you learn Route 53, I will show you how to buy your own domain name from the GoDaddy or any other website, and you can purchase it and you can configure it with your own Route 53. So now from here you can access your website, not using the public API. Instead, you can use your own domain name. And then comes the cloud formation. So cloud formation is a really important topic. So every cloud provider have their own tool. Like we have cloud formation, and Azure will have their own ARM templates. They have their own ARM templates, and Google have CDM templates actually. So like that, every cloud provider have their own service. So cloud formation is what? What is a cloud formation? So if you learn, if you heard about Terraform, it is same like Terraform. So that means it is a infrastructure management tool. It is a infrastructure management tool. So that means you can create whatever you discussed till now. Everything you can create. See, we talked about CLI. CLI, I told you, without GUI, you can create your services with the commands. Okay, but at least you have to write the command, right? So, for example, assume a team asked us to create 20 machines with the various infrastructure interconnected. It took you 1 week time to set up that infrastructure, and after 3 months or 6 months they said that the product is completed. We may need it later on, but you can remove the infrastructure for now. Then you will delete the complete infrastructure. But again, after some 3 months, they come back and they asked us to recreate the same infrastructure, which it took it's 1 week for you, for example. So then again, you have to do it from scratch. It will time consuming concept, right? So you can use cloud formation. So using the cloud formation, you can write script using JSON or YAML. YAML is a yet another markup language, very simple one actually. It's easier when compared with JSON. So you can write a script actually. It's a script means if you're not having any background of writing any scripts, no worries. So it's a very simple one actually. It's very easy. So you will get habituated if you when you practice it. So using the script, no, you can write the infrastructure requirements in the form of script. Then you can write using that script. You can generate. You can execute it. Once you execute it, no, your cloud formation will create the infrastructure as per your instructions in the script, right? So after 6 months, if they ask you to destroy that complete infrastructure, you can go to cloud formation, and in that you can select a button called delete button. The whole infrastructure will be deleted. And again, if they come back 3 months later on, because you have the script already saved, you can rerun your script again. Within 2-3 minutes, you will recreate the complete infrastructure again. So that means it saves a lot of time, and it avoids a lot of errors also. Sometimes you may forget to delete some resources. Even they ask you to delete, you forget for some time. No, then at that time more bills will be generated. So that is a problem, right? So that is the reason you can better depends on these infrastructure management tools like CloudFormation, like ARM templates in Azure, like CDM in Google, or Terraform, right? That is about our course which we are covering. But in between this is a customized course actually. It's customized one. So that means you can, in between the courses going on, in between, if you're interested on any topic, you can tell me that also. I will include it. This is a standard course actually I teach.